Hi everyone. Now we are going to discuss the part 3, the last 5 questions. And the very first question is obtain the expression for the fringe width, either dark or bright fringe in interference pattern. So it is all about Young's double slit experiment. So the thing is about fringe width. Fringe width beta is given by lambda d by d, where lambda is wavelength of light and capital D is distance between two slits, distance between slits and screen, and small d is distance between two slits. So this is the equation of fringe width in interference pattern. Now, when you consider how to derive this one, we need to understand about Young's double slit experiment. So Young's double slit experiment. So consider there is a source S of monochromatic light. Now, what we have to do is arrange an opaque object in front of it with two small or narrow holes as shown. Now, what will happen is light enters or passes through holes so that they act like two coherent sources, because interference pattern to be observed means the two sources from which light waves come and interfere, they must be coherent and the wavelength must be monochromatic. Then only we can observe the interference pattern. Now, here, if you consider, so light waves coming from S1, S2 interfere and a pattern of alternative bright and dark fringes observed on the screen arranged at a distance capital D from the slits. Now, here consider a point P on the screen as shown. Now see here, this is one source actually, capital S. This is one opaque object, and so here one opaque object with two holes. One is S1, another one is S2, and the distance between them is D. Now light is coming from the source and it will enter through the two holes, and on the screen, which is arranged at a distance D, we can have the interference pattern, so that at the central portion, the light coming from both the light waves travel same distance, that means path difference 0, so that the light intensity becomes maximum, and here we call that one bright light spot will be there, that we call it as bright fringe. Now, similar way, when you consider any point on the screen at a distance, let's take yn from the central fringe or from the center of the screen. One light ray passes from the source S1, another will travel from S2. So that here if you consider, see, this is S1, this is S2, and this is the distance between them D, and there is a point now like this. Now this is capital D. Now this is the central line. Now if you consider the angular position of that point is theta, then the path difference between the two light waves coming from these two. So this is the additional path traveled by the light wave traveling from S2. So from S1 one light is traveling, from S2 another light is traveling, and there is a path difference. And if you consider the right angle triangle, then this is theta means, then this will become theta. Then sin theta will become opposite side delta x by d, so that the path difference delta x equal to d sin theta. But as theta is very small, sin theta approximately equal to tan theta approximately equal to theta. So here tan theta, when you consider, see this triangle, this one and this one. So the triangle, when you consider like this is the central line. This is theta, this is yn, and this is capital D. So that tan theta equal to opposite by adjacent yn by d, that is also equal to sin theta. So tan theta is approximately equal to sin theta, that is yn by d. So that now the path difference between the two light waves delta x will become d into sin theta, nothing but yn by capital D. Now from this you can take that if delta x equal to n lambda, that means this is the condition for constructive interference. Then point P will become bright fringe. So that yn d by capital D equal to n lambda implies yn equal to n lambda d by d. This is the distance of nth bright fringe, where n equal to 0, 1, 2, 3, so on. N equal to 0 corresponds to central bright fringe. Now, similar way, if that point is like if delta x equal to 2n minus 1 lambda by 2, then it is called destructive interference. So, in that case, then point P will become dark fringe. That means zero intensity. Then yn will become 2n minus 1 lambda d by 2d, where n values start from 1, 2, 3, so on. So this is how you have to understand how the bright and dark fringe will form and what is the path difference at any point for the light waves coming from S1 and S2, and what is the condition to that point to be bright fringe or dark fringe. Now, when you consider such fringe pattern, see here, the fringe pattern is like this now. So when you consider, so this is bright fringe. Now, alternative, bright and dark fringes will be there. So above and below the central fringe. Now when you consider this one, or when you consider this one, so the distance between successive bright or dark fringes is called fringe width. Now that is beta equal to yn plus 1 minus yn. Let's take bright fringe. So n lambda d by d minus n lambda d by d. So n plus 1 fringe means n plus 1. Nth fringe means n, successive, like fifth fringe and fourth fringe. So here 5 will come, here 4 will come, like that. Then if you subtract, what you will get? Lambda d by d. So therefore, the fringe width will become lambda d by d. You can take even dark fringe also. Same answer you will get it. So that is what the derivation for dark or bright fringe width in interference pattern, or that is what you can derive the fringe width in interference pattern using Young's double slit experiment. So just try to understand what is the condition of constructive and destructive interference and how to find the path difference between the light waves coming from S1 and S2. Then how to equate the two condition. Then how to derive the relation for fringe width. Now, next question is, what is photoelectric effect and explain experimental results of photoelectric effect. So here, the very first thing is what we have to understand is what is emission of electrons. See, when electrons emit from a metal surface, then we call it as emission of electrons. Then we call it as emission of electrons. Now, when you consider photoelectric emission or photoelectric effect, now when electrons emit from a metal surface, when light energy falls on it, then it is defined as photoelectric effect or photoelectric emission of electrons. That is the definition of photoelectric effect. So emission of electrons with the help of the required energy in the form of light energy, we call it as photoelectric effect. Now, also you have to mention that the emitted electrons, we call them as photoelectrons, photoelectrons. And also mention that photoelectrons causes photo current. So photoelectrons causes photocurrent. So that is what the definition of photoelectric effect. Now, to understand this, they have taken one experimental arrangement. Now, what is that experimental arrangement? See here, the experimental see here, experimental study of photoelectric effect. So what is experimental study of photoelectric effect? Now, consider an experimental setup as shown below, which consists two electrodes, cathode and anode, inside a vacuum chamber, through which light can enter. Like, see, there is one cathode, there is one anode. Now both we will arrange in a chamber and we will connect them so that here light can come and fall on this cathode and this is anode. So that when light falls on it, electrons can come out. That is what the simple arrangement. Now, the first thing is when light falls on it, when light falls on metal, that is nothing but cathode, such that photon energy E greater than or equal to pi, then electron emission occurs, where pi is called what? Work function. The minimum energy needed to emit the electrons from the surface. Now the photon energy, because Einstein gave the explanation that when light falls on the metal surface, that light is nothing but sum of a small pocket of energies, and each pocket of energy we call it as like photon energy, and one electron can take only one photon energy, and if that energy is sufficient, then electron will come out, otherwise electron will just excite and go back to the same level. So that is what the thing. So that here when the photon energy, when you consider that must be greater or equal to pi, then according to Einstein photoelectric equation, that is E minus pi equal to K maximum, or H nu minus H nu not equal to K maximum. Now here what they have done is, initially when anode potential is zero, there is a small amount of photocurrent. As we increase positive potential of anode, photocurrent increases and becomes saturated. But when we give negative potential to anode, photocurrent decreases, and at a particular value of negative anode potential, photocurrent becomes zero. That is what they observed. That, see, if you take the graph between current and anode potential, now initially when anode potential is there, there is one current, then slowly it increases and becomes saturated. And when you give negative potential, then it keep on decreases and it becomes at particular value, that we call it as minus V naught. This V naught is called stopping potential. Stopping potential means the negative anode potential V naught is nothing but negative anode potential, which can stop electron with maximum kinetic energy, so that all the remaining electrons also can be stopped, so that the total current will become zero. So the kinetic energy maximum equal to EV naught, because the work done equal to change in kinetic energy, and the work done in Accelerating or decelerating a charge through a potential difference is charge into potential difference. So Q into V. So K maximum will become EV naught. So that the Einstein photoelectric equation will become E minus pi equal to K maximum equal to EV naught. So this is the Einstein photoelectric equation. And from this, like when you consider the equation h nu minus h nu not equal to EV naught, then nu minus nu naught equal to or nu equal to E by h into V naught plus nu naught. Now you can draw the graph between frequency and stopping potential also. Or in reverse also you can write it. See, V naught will become h by E into nu minus h by E or h nu naught by E. Now V naught is on y axis, nu on x axis. Then if you try to draw the graph, then here V naught and here frequency, then y equal to mx minus c form. So positive slope and negative intercept, and the intercept will become h nu naught by E, and the slope will become, slope of the graph will become h by E. Also, they observed that as frequency increases, stopping potential also increases. That's why when you take different frequencies, see here, same intensity of light but different frequencies when you consider. So the graph looks like this. So minus V naught 1, minus V naught 2, minus V naught 3, and the corresponding frequencies nu 1, nu 2, nu 3. Saturation current is same. That means intensities are same. I1 equal to I2 equal to I3. But here nu 3 greater than nu 2 greater than nu 1. Because the greater the frequency, greater the stopping potential. Also they observed that photocurrent is directly proportional to intensity. That means when you take a simple graph between photocurrent and intensity, it is a straight line passing through origin. So this is the current and this is the intensity. So these are all things they observed, and mainly the conclusion is when the how to increase the photocurrent or how to reduce the photocurrent, and for what value of anode potential the photocurrent will become completely zero. That is what they try to do with this experimental study. So all these graphs also important. So try to understand what are all the graphs are there and what is the meaning of stopping potential and how current will vary. So everything you need to understand properly. So now the next question is obtain the expression for radius and energy of nth orbit electron in hydrogen atom using Bohr's postulate. Now the very first thing to understand this question, let's write down Bohr's postulates. See, the very first thing what he will tell is all the electrons revolve around the nucleus in circular orbits. In circular orbitals, where the circular orbitals numbers are like n equal to 1, 2, 3, denoted by like K, L, M, N, so on. So, when you consider the second postulate, see here, this is nucleus, positive nucleus. So, n equal to 1, n equal to 2, so on. Now, when you consider nth orbit, so the electron will move with a particular speed. It is in a particular orbit of radius Rn. Then what he said is angular momentum of nth orbit electron is given by Ln equal to angular momentum of a particle is MVR, that is quantized descent. Quantization means integral multiples of one base quantity. Here the base quantity is h by 2 pi. So first orbit means n equal to 1. Third orbit electron angular momentum means 3h by 2 pi. Like that, only n value changes, but the basic value h by 2 pi remains constant. That is what the second postulate. And the third postulate, when you consider, when electron jumps from higher orbital to lower orbital, then energy, nothing but radiation, emits in the form of photon. So the emitted photon energy E equal to h nu equal to energy of higher energy level minus energy of lower energy level. So what he concluded is all the electrons revolve around the nucleus in circular orbits whose angular momentum is quantized, and each orbital has some binding energy. And when electron jumps from higher orbital to lower orbital, there is a radiation emits in the form of photon, and that photon energy is given by this equation, energy of higher level minus energy of lower level. Now when you consider the derivation for the radius and energy of nth orbit electron. So the derivation of radius and energy of electron in nth orbital. Now we have to understand this one. Now when you consider nth orbit electron, so first consider an electron in nth orbit of an atom as shown. Now you consider one nucleus with the atomic number Z and one electron here. It is moving with a speed Vn in a circular orbit of radius Rn. Then according to Second postulate, MVN Rn equal to NH by 2 pi, the very first thing. Now, next thing is every particle in circular motion must be provided centripetal force. So here the required centripetal force will be provided from the electrostatic attraction between the electron and the nucleus. Here centripetal force equal to mv square by r, and that will be provided from the electrostatic force, that is 1 by 4 pi epsilon naught q1. One charge is electron, another charge is nucleus, means protons charge. So one proton means E. Inside the nucleus, Z protons will be there, Ze by R square. So that here what you do is Rn get cancelled. So Rn you bring this side. So M Vn Rn into Vn equal to 1 by 4 pi epsilon naught Ze square. So what I have written is Vn square, I have written as Vn into Vn. So that MVn Rn place, I can write it as NH by 2 pi into Vn equal to Ze square by 4 pi epsilon naught, implies Vn equal to Ze square. But here pi get cancelled, 2 2s are. So Ze square by NH you bring this side, 2 NH epsilon naught. So Vn is directly proportional to Z by N. This is the equation for velocity. But we want radius. So radius, if you want, you consider the same equation again. MVn Rn equal to NH by 2 pi implies Rn equal to NH by 2 pi MVn. Now NH by 2 pi M Vn value you substitute, Z square by 2 NH epsilon naught. 2 get cancelled. So Rn will become NH times NH epsilon naught will go to numerator, and pi M E square Z equal to N into N square, H into H square into epsilon naught by pi M E square Z. So this is the radius of the nth orbit, where Rn is proportional to N square by Z. So that is what you need to understand. So radius of nth orbit. So one equation we have derived. So it's all just manipulation of equations, whatever you have. So just try to understand how the equations we are taking, how we are substituting one equation in another one. First we have taken the quantization of angular momentum equation. Then we have taken centripetal force equation. Then we try to combine both the equations. Then similar way, when you consider kinetic energy of electron, so Kn equal to half m Vn square. So half m Vn square means Z square by 2 NH epsilon naught whole square. If you do the square, Kn will become m Z square e power 4 by 8 n square h square epsilon naught square. This is the kinetic energy. Similar way, when you consider potential energy of the electron, that is given by potential energy of the electron means the electrostatic potential energy of electron and nucleus. That is 1 by 4 pi epsilon naught. Q1, Q2 by R. Q1 is minus E. Q2 is ZE by Rn. As we know the Rn value, just substitute it. Rn value is n square h square epsilon naught by pi m e square z. So that when you take the potential energy equation, it will become minus m z square e power 4 by 4 it will become 4 n square h square epsilon naught square. Now comes the total energy equation. Now what is the total energy will become? Total energy En will become Kn plus Un. That will become Kn plus Un means Kn and Un, when you consider the common thing, if you take mz square e power 4 by n square h square epsilon naught square, Kn means 1 by 8 minus Un is minus 1 by 4. So if you do that one, then you will get minus mz square e power 4 by 8 n square h square epsilon naught square. So this is the total energy of the electron in the nth orbit, where En is directly proportional to z square by n square, or En also can be written as minus 13.6 electron volt into z square by n square. Similar way, you can also write for Rn. Rn is 0.53 angstroms into n square by z. So just purely manipulation of equations. Whatever three equations we have, three equations. So we are just trying to manipulate all those equations. So just try to understand, then you will get it, and practice 2-3 times on your own. Now the next question is, what is law of radioactivity, and derive the expression for number of atoms undecayed after time t. Now the very first thing is, what is law of radioactivity? This is what we have to understand. Now, so when we consider any radioactive element, so the rate of disintegration, the rate of decay or disintegration of radioactive element is given by dN by dt is proportional to minus n, where n is, where capital N is number of atoms undecayed after a time t. That is, dN by dt is proportional to minus n, and here negative sign represents n value keep on decreases. As number of atoms undergoing decay keep on increases, number of undecayed atoms keep on decreases. One by one atom is undergoing decay process, so that number of undecayed particles keep on decreases. That is why we are representing one negative sign. And here dn by dt equal to minus lambda n, where lambda is called disintegration constant. Lambda is called disintegration constant, and this dn by dt also called as rate of decay, also we call it as activity, which we denote with capital A. So A equal to minus lambda n. So this is called law of radioactivity. Law of radioactivity. So one by one atom undergoing decay process. Now the number of atoms undecayed after a time t is given by n equal to n naught into e power minus lambda t, where n naught is initial number of atoms. Initial number of atoms. Now to prove this, let's consider this way. Now a consider a radioactive element. Consider one radioactive element having n naught number of atoms at t equal to 0. Now, after a time t, let number of atoms undecayed is n, then dn by dt equal to minus lambda n implies dn by n equal to minus lambda dt. Now, integrate both sides or apply integration on both sides. Integration dn by n equal to integration minus lambda dt from 0 to time. So in a time of t time. So the number reduced from n naught to n. Initial number of atoms undecayed is n naught. After time t, number of atoms remained undecayed is n. Now here we use one formula, integration 1 by x dx is log x base e. So that here the equation will become dn by n means log n base e, and from n naught to n equal to minus lambda is constant, integration dt. Now here minus lambda integration dt will become t 0 to t. Now how do we substitute the limits? Final limit minus initial limit equal to minus lambda t minus 0 equal to minus lambda t. Now here one more formula we use, that log x minus log y equal to log of x by y. Similar way here log n minus log n naught will become log n by n naught base e equal to minus lambda t. And one more formula also we will use here, log x base e equal to y means x equal to e power y. So this is another formula. So that here in place of x, what is there? N by n naught equal to e power y place, what is there? Lambda t. So that now the equation will become number of atoms undecayed will become n naught into e power minus lambda t. So hence we can say that proved. So here what we have considered is first what is law of radioactive decay, then after defining that what is activity and all, then what is the main thing here is you take the equation of law of radioactivity and go for integration within the limits we have. In a time of 0 to t, the number of atoms undecayed reduced from n0 to n, so that when you integrate within the limits, then we have to use few logarithmic formulas, and finally we got the equation n equal to n naught into e power minus lambda t. So that when you consider the graph, it is like variation. What kind of variation? Exponential variation. At t equal to 0, e power 0, 1. So initial number of atoms are n naught at t equal to 0. As time increases, n value keep on decreases and it tends to 0. As t tends to infinity, n tends to 0 because e power minus infinity is how much? 0. So exponential decrease. Exponential decrease. That is the variation of number of atoms undecayed with respect to time. Now, the last and final question, that is, what is half wave and full wave rectifier? Explain how. Now, the next question, the last and final question, that is rectifier, half wave and full wave rectifier. Now let us try to find out, first define what is rectifier. See, rectifier, it is a device. It is a device which converts alternating current into direct current, unidirectional current. So a device which converts AC into DC is defined as rectifier. That is what the main thing. Now here when you consider rectifier, it mainly works on the principle of electromagnetic induction. So it works based on the principle of electromagnetic induction. Now, when an AC input given in the primary coil, then EMF induces in the secondary coil, which will be connected to diode or diodes, so that we get DC output. So usually let us consider the very first thing when we consider like half wave rectifier. Now a rectifier which consists only one diode as shown. Like, see, this is primary coil, this is secondary coil, and here one diode will be connected, and here you connect one load resistor across which we will collect output. So here we apply our input across the
primary coil, which is near to the secondary coil. So when we give AC input to the primary coil, for positive cycle, if current flows through the diode is from P to N, that is forward bias. Then diode conducts, and for negative half cycle, current flows from N to P, that is reverse bias. But in reverse bias, that is reverse current is approximately zero, that is diode won't conduct. Therefore, output will become zero. Output will become how much? Zero. So just like, see here first current is flowing through this one. Now this is P terminal, this is N terminal. When current is flowing from P to N, the diode is said to be in forward bias. Then current is due to majority charge carrier, so large current will come. Then we get the output across the load resistor as like, if this is input, then this is input. Now output, what we will get, it is only positive cycle will come out, but the negative cycle will not come out. So this is the output. Now this is DC, unidirectional. This is AC. So the now AC converted into DC, as negative half cycle got restricted, as negative half cycle, during the negative half cycle, the diode is having the current from N to P, that is reverse bias, so that the current is approximately zero. So this way, by vanishing the negative half cycle, we can convert AC into DC. But here the problem is we are losing half of the cycle. So to compensate this, they have arranged one more arrangement, that is one more diode they arranged. Then we call it as full wave rectifier, which converted full wave into DC, and it consists two diodes. Now let's take the diagram. Now you apply the same way. This is primary coil. Now here we are giving the input. Now here this is the secondary coil. Now here one diode D1. Now here one diode D2. Now you can connect in this way. Now this is our load resistor, across which now we have to collect the output resistance. Now here you have to observe properly that when positive cycle of input flows through primary coil. Then in diode D1, then diode D1 is in forward bias and diode D2 will be in reverse bias. See, when current induces in this manner, see the D1 from here it is going. So now here when current try to divide, then the D2 will become reverse bias. So current will not flow through it. Current will flow through this load resistor only in this manner. Now for negative half cycle, current direction becomes such a way that now D2 will be in forward bias and D1 will be in reverse bias. Now the direction got reversed. Now just like now the direction got reversed means now the current will flow like this. Now the current will not enter here. So here when diode D1 is conducted, D2 is not conducting. When D2 conducts, D1 is not conducting. So that now see in first case, this is the coil and the current flows like this. Now current is flowing down. Now in the second case, current will flow like this. It will complete the circuit like this. Now there is no current in diode D1. Now D1 is not conducted. So this is the direction of current now. So it completed the circuit. Now here the direction is like this. So in both the cases, when you consider, in one case one diode is conducting, in another case another diode is conducting, but the direction of current across the load resistor, that is output, is same. So that here when you apply an AC input, this is the input, AC input. Now it is converting into DC output, which is like this. For all the cycles, the current through the load resistor is same direction. So this is what the conversion of alternating current into direct current, either using one diode or two diodes, that is either half wave rectifier or full wave rectifier. This is how you need to understand and you have to explain in a simple terms. So what is half wave rectifier and what is full wave rectifier? So hope everyone understood. Try to revise everything and try to practice everything on your own. One of the most important questions which they have asked many times in the previous year's examinations, right? So thank you all the best for your examination. Thank you.